Good morning, students. I hope all of you are safe at your house. Today we are going to demonstrate you the instrumentation experiments which you have not done. So today we will be starting the first experiment. That is, if you open your manual book, you will come to know. The first experiment is determination of pKa value of weak acid using pH meter. So we are using the pH meter and we have to determine the pKa value of given weak acid using pH meter. So in this experiment you have to understand two words. One is you have to know what is weak acid and you have to understand what is pKa and why we are measuring the pH of the solution to determine the pKa. So first we have to know what is weak acid and what is the difference between strong acid and weak acid. You all know that weak acids are the acids which partially or incompletely ionizes in its aqueous solution. That means if you take it in water, they will be partially ionized. For example, if you take acetic acid, its formula is CH3COOH, or if you take formic acid, HCOOH, these two are the weak acids. So if you take it in water, they will be partially ionized as acetate ions and H+ ions, unlike the strong acids like HCl and nitric acid or sulfuric acid, because the strong acids are the acids which completely ionizes in their aqueous solutions. So now in this experiment, we are taking weak acid, mainly the acetic acid we are taking in a beaker, and we using a pH meter to determine pKa. What is pKa? What is Ka stands for in pKa? The Ka stands for the dissociation constant of weak acid. So pKa is equal to minus log to the base 10 of the concentration Ka. So you are determining the pH, and from the pH we are going to determine the pKa of weak acid. Okay, now coming first, I will explain to you the instrument. This is the pH meter, and this pH meter is connected to an electrode, and this is the glass electrode. I have studied in your theory class the construction and working of a glass electrode, but this electrode which we are using in this experiment called combined glass electrode. That means it consists of glass electrode and it consists of a calomel electrode inside, which are sealed inside a glass tube. In this, the glass electrode acts as an anode and the calomel electrode acts as a reference electrode. And this glass electrode is also called as ion selective electrode. It is also called as membrane electrode. Why it is called as ion selective electrode is, it is made up of a bulb, and this bulb is made up of a special type of membrane which is selective to H+ ions present in the solution. That's why it is called as hydrogen ion selective ion electrode. So this is selective to only certain type of ions, mainly the H+ ions present in the solution. That's why this electrode, the combined glass electrode, is called as an ion selective electrode, or it is also called as membrane electrode, where it consists of a glass electrode and a calomel electrode. Glass electrode acts as an anode and the calomel electrode acts as a cathode in this. So okay, now this electrode which is connected to the pH meter, now we have to put it in. First we have to clean this by putting it in a distilled water, and we should be very careful with the glass electrode because this is highly sensitive. So first we have to take distilled water and we have to clean this glass electrode on all sides with the distilled water, and now take it out. And we have to take a beaker containing weak acid, and we should not add any water into it, and simply we have to dip the combined glass electrode in the weak acid solution. Now we have to switch on the instrument and when you switch on the instrument, it will display to you the pH of the solution. The pH of the acetic acid which is taken in the beaker, now it is showing as 3.17. Okay, now we are taking a burette to do the experiment, and this is unlike a normal burette. This is called as a micro burette, and the capacity of this burette is only 25 ml, whereas in case of titration experiments, you will be using a 50 ml burette. Now we are using only a 25 ml burette, and this burette is filled with 0.5 normal sodium hydroxide solution carefully up to the mark, and see that the nozzle also should be filled with sodium hydroxide solution. And after filling this burette with the sodium hydroxide, you have to keep it to the stand in such a way that the nozzle of the burette should be inside the beaker. This is called the setting of the apparatus. Okay, now we have taken sodium hydroxide in the burette. In the beaker we have taken acetic acid. So the reaction between acid and base, so it is one type of neutralization reaction. Okay, now without adding sodium hydroxide from the burette, now we have to note down what is the pH of the weak acid solution, which it is showing as 3.16. So there is a one tabular column in this. In your, all of you take out your manual books and note down without adding sodium hydroxide what is the pH of the solution. It is showing as 3.15. Please make a note of 3.15 without adding sodium hydroxide from the burette. Now we have to add sodium hydroxide from the burette slowly. See that we have to add exactly 0.5 ml. Only 0.5 ml. That means from 0 to 0.5 ml of sodium hydroxide we have to add. And after adding that, we have to shake the solution. So when you shake the solution, the neutralization reaction occurs between the base and the acid. So that means the H plus ions which are present here getting neutralized by the base. So the H plus ion concentration is decreasing. That means the pH of the solution increases. So now with the addition of 0.5 ml of sodium hydroxide, now the pH of the solution is 3.93. So now we have to note down as 3.93 with the addition of 0.5 ml of sodium hydroxide from the burette. Now again I am adding 0.5 ml. That means from 0.5 to 1 ml of I am adding. So after addition of 0.5 ml, now again I am shaking the solution to complete the reaction. So when I am shaking that, again the H plus ions are getting neutralized. And now the pH of the solution is increasing. Now it is showing 4.30. Again I have noted down for 1. Now again you have to add from 1 to 1.5 ml. Again after addition of 0.5 ml, you have to shake the solution and note down the pH. So you will observe with the addition of 0.5 ml continuously the pH of the solution, now it is increasing because the H plus ion concentration is decreasing in the solution. So like this, you have to continue the reaction with the addition of 0.5 ml all the time, and after addition of each 0.5 ml, you have to shake the solution and you have to note down the pH of the solution as 4.7. Again, you have to add 0.5 ml. Only 0.5 ml, not more than that, because we need more number of readings so to plot the graph. So again we have to shake the solution, and this electrode is selective to H plus ions, so it will give you the pH of the solution. Now it is 4.90. Now again we have to add 0.5 ml. Again after addition of 0.5 ml, we have to shake the solution
because when the H plus ion concentration is decreasing, it takes time for the neutralization reaction to occur. So we have to shake the solution for 2-3 seconds and we have to note down the pH of the solution. Now it is 5.03. Again, you have to add 0.5 ml. So until now I have added 3.5 ml I have added. Again, we have to shake. See, now the pH is increasing further because the H plus ion concentration is decreasing. So now it is 5.17. So again you have to add 0.5 ml of sodium hydroxide from the burette. Again you have to shake the solution and note down, now it is 5.30. Now again we have to add 0.5 ml and note down, shake the solution. It's a very simple experiment you have to follow, but while you are doing the experiment, you should not touch any of these knobs which are fixed to the instrument because the instrument is calibrated, so should not touch any of the knobs. Simply you have to measure, you have to note down the value what it is showing. Again we have to add 0.5 ml of sodium hydroxide from the burette and again we have to shake the solution well. Should be very careful when we are shaking. See that the glass rod should not touch the glass electrode. Now it is showing 5.74. Now again I am noting down, I am adding 0.5 ml. Now it is showing, see that it's increasing drastically. So now it is 6.04. Now again I am adding 0.5 ml. Now it is exactly 6 ml I have added. See now the pH of the solution is increasing suddenly from 6 to 7 to 8 to 9. That means all the H plus ions are completely neutralized by the sodium hydroxide. It is an indication that the reaction is completed. There are no more H plus ions in the solution. All H plus ions are neutralized. See, suddenly the pH of the solution is increased from 6 to 8.5. So you have to stabilize it and you have to note down the reading 8.51. Now I am adding from 6 ml to 6.5 ml. And again I am noting down. See now further it is increasing from 8 to 9. 9.5. It is showing 8 to 9.5, 9.8, 10. So it is further increasing. We have to note down a constant reading. See that the reaction is completed. So now it is showing 10.64. Now we have to add, now the reaction is completed. After this we have to add again 0.5 ml increments and shake the solution and note down the readings. But you will not observe now a drastic change in the pH because there are no more H plus ions present in the solution. All H plus ions are completely neutralized by the base. That's why you will not observe a change in the pH. Now it is completely comes to basic medium. So now it is again 10.8 only. There is no change. So when there is no much change, you have to add 2-3 times 0.5 ml increments and shake the solution and note down the readings. There is no much change, 10.8 only it is showing. So again we are adding 0.5 ml and again shaking the solution. So even after addition of 0.5, 0.5, 0.5, there is no much change. So 10.8 to 10.9 only. So now we will stop doing the experiment. This is the completion of the experiment. That means after getting a jump in the pH, we have to take 2 more readings. Then we have to stop doing the experiment. This is the demonstration of the experiment. So after doing the experiment, again you have to take out your glass electrode out. Take out the beaker and put it back, this glass electrode, in the distilled water very carefully, because this is a highly sensitive electrode. So this is the experiment conduction. This is the first experiment which we have done today, that is for the determination of pKa of weak acid using pH meter. Now this is the first part. In the second video, I will explain to you how to do the calculation part. I hope all of you have understood how to do the experiment. Only thing is, you should be very careful with the instrument, with the electrodes what we are using. So for pH meter, you have to remember that we are using a combined glass electrode, taking weak acid in the beaker, taking sodium hydroxide in the burette, adding in 0.5 ml increments, shaking the solution, and note down the pH of the solution. I hope all of you have understood. Thank you. Okay, now coming to the second video for the calculation of determination of pKa. Now we have noted down in the tabular column whatever the pH we have measured using the instrument here. 0.0 sodium hydroxide to 7.5 ml of sodium hydroxide we have added. Each addition of after 0.5 ml we have noted down the pH of the solution. Now we have to fill this tabular column for doing the calculation part. So for 0.0, there is no delta pH, no delta V, no delta pH by delta V. Okay, now for 0.5 ml, the delta pH is the difference in the pH of previous reading and present reading. Please try to understand. The delta pH is the difference in pH of the present reading minus the previous reading. You have to note down here. And the delta V, the difference of the delta V always 0.5 ml. So the delta V is 0.5 ml all the time, because we are adding every time 0.5 ml increments of sodium hydroxide. So after filling this column, finding out the difference in the pH of previous reading and present reading, you note down the values here. And the delta V is always 0.5. And then you calculate delta pH by delta V here. So once if you fill this table ready, now you have to take out 2 graph sheets to plot the graphs to find out the pKa. So take the first graph. So first graph, you will be taking the graph sheet, y-axis and x-axis. And the first graph you are plotting, taking volume of sodium hydroxide on x-axis and delta pH by delta V on y-axis. So you have to take the scale. Each unit is 0.5 ml of sodium hydroxide added, and each unit on y-axis you have to take 0.4 of delta pH by delta V. I will send you the scanned copy of this graph. So for these readings, you fill the table, plot the graph. So for plotting the graph, you indicate all these points in the graph and draw a smooth curve, and suddenly there will be a drastic increase in the pH, and after that you will be having 2 readings and you have to plot a graph like this. And from the peak of the graph, you have to draw a straight line onto the x-axis, and this point where it is touching the x-axis is called as equivalence point. So in titration experiment, you are calling this point as end point, where end point is the point exactly where the indicator is changing the color. You are noting down as end point. But in instrumentation experiments, you will call that end point as equivalence point, because exactly at this point the neutralization reaction is getting completed. So this is one graph to find out the equivalence point of the experiment. So taking volume of sodium hydroxide on x-axis and delta pH by delta V on y-axis and indicating all the points and plotting the graph. Okay, now you are plotting the second graph. Second graph, again x-axis, y-axis, taking volume of sodium hydroxide on x-axis and pH. You have to take the pH, whatever you have noted down here, on y-axis. And indicate all the points and you will get an S-shaped graph like this. So in this graph, from the first graph, you will be knowing the equivalence point. Here the equivalence point is 6. So exactly at 6 equivalence point, in the S-shaped graph, you draw a straight line onto the x-axis. Again at 6 is the equivalence point. Half of that equivalence point, so exactly half of 6 is 3. So at 3, you are drawing a straight line onto the graph and drawing one more straight line onto the y-axis. Please follow. Equivalence point is 6. Half of the equivalence point is 3. At 3, you are drawing a straight line onto the graph, drawing one more straight line onto the y-axis. Okay. Now, whatever the pH we are observing at half equivalence point is the pKa value of the given weak acid. Please, again I am repeating, this is very important Viva question they will ask you. Whatever the pH we are observing at half equivalence point is the pKa. Okay, from these graphs there is no separate calculation part. Directly you have to mention here in the observation column the equivalence point 6, half equivalence point 3.0, the pH at half equivalence point, whatever the pH we are observing at half equivalence point is the, you are noting down. So the pKa value of given weak acid is equal to whatever the pH at half equivalence point is the pKa, which is nothing but your result. So the result is pKa value of given weak acid is the acetic acid we have taken. So it generally for the acetic acid the pKa value will range from 4.5 to 5. So between any range 4.5 to 5 you will get the pKa value. Now you will get a doubt how this pKa is related to pH. According to Henderson's Hasselbalch equation, if you see in the Viva questions, the question number 7, how are the pH and pKa related? So according to Henderson's Hasselbalch equation, pH is equal to pKa plus log to the base 10 concentration of salt by concentration of acid. This is the equation. At half equivalence point, what happens is the concentration of salt is equal to concentration of acid. So this becomes 1. So therefore, whatever the pH we are observing at half equivalence point, it becomes the pKa of given weak acid. So please follow this carefully, read the Viva questions, you will understand better, listen to the video, you can understand further, and when you are coming here, if you are having further any doubts, I will clarify to you and we will do the experiment in the lab. Meanwhile, you record all these things, do the calculation part, plot the graphs, find out equivalence point, find out half equivalence point and measure the pH at half equivalence point. That is nothing but the pKa value of the given weak acid. So this is the first experiment in your instrumentation experiments, that is the determination of pKa value of weak acid using pH meter.